Hello viewers, in today's class we are going to discuss another problem from integral inequalities, right? So in this lecture we'll see a very important problem from estimation of integrals, in which we are given an integral I is equal to 0 to 2 pi, and we have dx over 5 plus 3 cos x. Then we have to show that the value of this integral I, it satisfies this inequality, that is I is greater than or equal to pi by 4 but less than or equal to pi, right? So without evaluating this integral, we have to arrive at this inequality. So let us start. So viewers, whenever we have to estimate integrals or we have to solve these kind of problems related to integral inequalities, we usually make use of different identities related to integrals. But here, to solve this problem, we'll use an important concept that is called mean value theorem for integrals, right? So mean value theorem for integrals is a very important uh, concept to prove these type of inequalities. So mean value theorem for integral says that if we have a function, say y is equal to f of x, and this function is continuous in the closed interval a comma b, then the value of this integral, this function f of x, that is the integral of f of x dx from x is equal to a to x is equal to b, is equal to b minus a times f of alpha, where alpha lies between a and b, right? So now if we compare this integral with this one, then f of x is equal to 1 over 5 plus 3 cos x, and the value of a is 0 and the value of b is 2 pi, right? So the lower limit is 0, the upper limit is 2 pi. So now using this mean value theorem, we can now write I, that is this integral, which is 0 to 2 pi dx over 5 plus 3 cos x, is equal to b minus a. B is 2 pi, a is 0, and f of alpha, right? Where alpha is some number which lies between 0 and 2 pi, right? So now we have this expression. So we can now write I, and here we have 2 pi minus 0 is 2 pi and f of alpha, right? Okay. Now f of alpha can be written by replacing x by alpha. So we can now write I is equal to 2 pi times 1 over 5 plus 3 cos alpha. So we can now write I is equal to 2 pi over 5 plus 3 times cosine of alpha. So now we have this expression, right? Now let us make use of some trigonometry here. So we know that the value of cosine of alpha, it lies between minus 1 and 1. That is, the minimum value of cos alpha is minus 1 and the maximum value of cos alpha is 1, right? And whenever alpha belongs to this interval, that is 0 to 2 pi, right? Okay, now see, in the denominator we have 5 plus 3 cos alpha. So let us multiply this inequality throughout by 3. So we have here minus 3, 3 ones are 3, here we have 3 cos alpha, and here we have 3 ones are 3, right? Now here we have a term 5, right? So what we will do, we'll add 5 throughout this inequality. So we have minus 3 plus 5, 3 cos alpha plus 5, and here we have 3 plus 5, right? So 5 minus 3 is 2, and here we have 5 plus 3 cos alpha, this is 8, right? So using this fundamental inequality from trigonometry, we have arrived at this inequality. So now let us divide this inequality throughout by 2 pi, because here we have a factor 2 pi, right? So what we will get here, we have 2 over 2 pi, then we have 5 plus 3 cos alpha divided by 2 pi, and here we have 8 divided by 2 pi, right? Now here we can cancel the common terms. So here we have 1 over pi. Then we have 5 plus 3 cos alpha over 2 pi, which can be written as 1 over I, right? Because I is 2 pi over 5 plus 3 cos alpha, and we can now write here the reciprocal of I, right? So this is 2 4s, so this is 4 over pi. So now let us take the reciprocal of all these three terms, right? So when we take the reciprocal of these three terms, then the direction of the inequality get reversed. So here we have pi, then here we have the sign of greater than or equal to, then here we have I, and here also the direction get reversed. So we have pi over 4, right? So we can also write this inequality as pi by 4 is less than or equal to I, that is less than or equal to pi, right? So this is our desired inequality which is to be proved. So viewers, this is how, by making use of the mean value theorem for integrals, we can solve these kind of integral inequalities.